Good afternoon. This is pack 6.2, preparation of benzoic acid. In front of me I have methyl benzoate, ethanol, and sodium hydroxide. I'm going to place them each into the pear-shaped glass right here. So I put 2 ml of the methyl benzoate, which is the reagent, 10 ml of the ethanol, which help mix the methyl benzoate and the sodium hydroxide, and 10 ml or 2 more sodium hydroxide, which is one of the other reagents. As you can see, when I mix it, there's 2 layers. I put a few anti-bumping granules into the solution in order to stop it bumping whilst I'm refluxing. Now I will place this onto the condenser. You can use a clip or you can't, or you don't need to, but I would like to use it. And then we turn on the condenser. You can see the water goes from the bottom to the top. A nice easy stream. Okay, I'm going to turn on the gas with the Bunsen burner. And then we just need to boil it for 15 minutes. Now, ethanol boils around 80 degrees, so it don't need to be violent. You just need to come to the near to the bottom of the condenser, and then you need to pull back down. As you can see, I'm using the blue flame. If you can, just find a position. You see how it's just boiling, but it's not over bubbling. So for me, this is the best position. Okay, I'll wash the pear-shaped glass with distilled water. And then place this solution together with the other solution. There you go. Now here's the solution, and then I add 10 drops of methyl orange. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. As you can see, it's a yellow color because of the sodium hydroxide. And now we add HCl in order to turn the sodium benzoate into benzoic acid. The methyl orange helps you see the color change as we do this. As you can see, it's slowly turning red. And then pink. You can see that it's becoming cloudy, which is the precipitate form of benzoic acid. It doesn't matter how much HCl you add. There you go. You can see the white precipitate. Now we just need to get rid of the solution. Place this into the tap. Now I'll put it under vacuum filtration. The clamp is useful to make sure that the water goes into the sink. Okay, I have one of these seals. This helps create a vacuum seal when you switch it on. So, you place this in, and then we place one of the filter papers, making sure that it's big enough to fill the bucknell funnel. Okay, so we turn on the water, and then we have to wet the filter paper to create the seal. As you can see, it's creating the seal. And now we slowly add our solution. And we clean the beaker with this water. To ensure we get all of the solid. Just push it in, and then we help create the seal. We clean it in order to remove the pink solution that's still locked into the solid. We do this 2 or 3 times, and as you can see, the pink solution is slowly disappearing. Making sure that if it's full, we empty it into the sink. And now we do it one more time. As you can see, the pink solution has now disappeared, and all we got left is a benzoic acid, the impure benzoic acid. So here's a beaker, and I can show you what it looks like. As you can see, the solid is quite wet and it's still very impure from maybe the sodium hydroxide or the ethanol that might still be remaining. And then we need to recrystallize it, which is in part B. But this is the end of part A for the preparation of benzoic acid. Of the preparation of benzoic acid. Part 2, Part 1, recrystallization. If you read your instructions, it says set up a water bath and place the boiling tube in the water bath. Unfortunately, we do not have a water bath that goes up to 100 degrees. So what I'm using is a beaker on a tripod with Bunsen burner. I'm going to pour some hot water inside the beaker, and this will act as a water bath. And now we add some distilled water into a boiling tube. And we let this boiling tube heat up, and I can transfer little bits of this boiling tube into the boiling tube containing my benzoic acid. Now, here's my impure benzoic acid that I made earlier. So you transfer most of it into the boiling tube, but you keep a little bit for your TLC later on. Benzoic acid is inside this boiling tube, and I will put it inside the water bath. Now this works because at high temperatures, more benzoic acid will dissolve than in smaller volumes of water. So it's insoluble at lower temperatures, but soluble at high temperatures. It's a pretty slow process as you want the minimum amount of water. If you put too much water, it will dissolve it completely, even in colder temperatures. As you can see, the benzoic acid is slowly dissolving. Magic. Now it has dissolved. Then we turn off the gas, and we wait for it to cool down. There you go. Now, if you want big crystals, you have to wait for it to cool down to room temperature in order to get the big crystals. Okay, left it to cool down, and now you can see the large crystals. Yeah. And now you just need to vacuum filtrate. So, the same process as before, we turn on the water. We wet the filter paper in order to create vacuum seal. And once that's done, you could just pour it in. And now we just clean it with more water. Once that has dried, we can start doing the melting point in order to determine whether it's pure benzoic acid. And that would be the second part of part 2. Okay, so now the benzoic acid is now nice and dry, and you can see the tiny needles of benzoic acid. Now we are trying to work out the melting point apparatus. We have the field biotube, a mercury thermometer, and a Bunsen. We get a closed melting point tube that is sealed in one end, and we slowly pour a little bit at a time into the tube. So when you get a little bit, then you just turn it upside down and just tap it in. When you have enough, you then put it so it's level with your thermometer. And then you put an elastic band on it to secure it in place. Then now it's secure. You push it up to the top. And then you put it inside the field tube. You don't want to fill it up. You don't want to fill it up to the top with glycerol because the pressure that builds up once it starts heating up. This works. The way this works is you heat up this corner of the field tube, and then it will. Then the heat will circulate around, so you see the temperature of the melting point. What we expect here is a uniform. It's a very sharp melting point. So if it melts at say 200 degrees, it should melt around that degrees. If it's impure, it will melt across a wider range of temperatures. As you can see, it starts moving, so the heat is slowly circling around, and it's done. And that's how you do the melting point. Now we wait for this to cool down, and then we can put the glycerol back inside the glycerol bottle.